Okay, so in this video, we're going to be looking at the laws of indices. And I just want to point out, in case anyone's wondering, what indices refers to. So I just want to make a note that indices happens to be the plural of index. So we say one index, but we have more than one indices, and that's just in case anyone was wondering. Okay, so we're going to be investigating the laws of indices, and to do that we're actually going to be looking at a few examples. Now, to illustrate the laws, I'm just going to give you a few brief examples. For example, 2 to the third times 2 squared. Now, from video 7.1, I'm sure you're able to expand these and of course arrive at an answer. 2 to the third happens to be 2 times 2 times 2, and 2 to the second power happens to be 2 times 2. So let's try to look at how many 2's I have and maintain the answer in index notation. So I have counting 1, 2, 3, 4, 5 2's. So I can write that final answer as 2 to the fifth power. Now I'd like us to look at something here. Is there any possible shorter way that I could have arrived at an answer of 5 looking at what I had with my indices there? Now this one is not too difficult. Of course I could have simply added, and let's just write this here, 2 to the third power plus the 2. So I could have added those indices to arrive at the answer of 5. Expanding it could have worked, but we're looking for shorter, smarter ways of doing our mathematics. So that's the first rule illustrated. Now let's look at another one. Now what if I try to divide? So let's say I had 2 to the third power divided by 2 to the second power. I'm actually just going to write this out in its expanded form. So 2 to the third power, we know, is 2 times 2 times 2 divided by 2 times 2. Yeah? So let's try to clean this up a bit and simplify anything that can be simplified. Well, I know my 2's can divide to give me 1, and I know those 2's can divide to give me 1, leaving me with an answer of 2. Is there any way that I can write 2 in index notation? That 2 can be written as 2 to the first power. I hope everyone is making a note of that. Now, let's just observe again. Is there any way that I could have arrived at an answer of 1 looking at my exponents only, trying to eliminate this working? Now, of course, you guessed it, I could have possibly just subtracted those indices. And I hope that is clear to everyone, giving me 2 to the 1, which is really just 2. Okay, good. Now, our final law of indices that we're going to be looking at is raising a power to a power. So let us say I had 2 to the third power and I wanted to square that. Let's try to simplify this. 2 to the third power squared is really just multiplying 2 to the third power times 2 to the third power, because that's what squaring is. But let's try to expand a bit more. What is 2 to the third power? We know that's 2 times 2 times 2 multiplied by 2 to the third power again, which is 2 times 2 times 2. Now let's try to condense and see how many 2's I have in all. Let's count. 1, 2, 3, 4, 5, 6 2's, which means in index notation I could simply write 2 to the sixth power. Now let's look and see, is there any way I could have come up with an answer of 6 without having to write the expanded form? And if I look at my indices, how could I have done that? Of course, I could have simply multiplied to get an answer of 6. Good. So those are pretty much the 3 basic rules. In your textbook, you will notice that the rules are pretty much written with a base of A. Now, I do want to point something out here. that when looking at indices, a few things have to be in place. The bases, in order to use my laws of indices, the bases must be the same. So in the example or in the notes from the book, you will see that the base is A. In the examples that I have used, my base is 2. But nonetheless, the bases must be the same in order for me to use those laws of indices. Well, let's jump right into our examples to see what we can get done here. Good. All right. So 2 to the 4th power times 2 to the 6th power. Now remember, we're not trying to expand as we did in our examples on the left-hand side of the screen. We're trying to use the laws of indices to come up with our answer in one go. So 2 to the 4th times 2 to the 6th power. Now, if you want to refer to either the notes in the book or the proofs that I've done on the left, you will see that you are supposed to be adding your indices, which means that my power is now going to be 10, because 4 plus 6, of course, gives us 10. And please note that the bases are the same. Good. So let's move on to example 1b. And 3 to the 7th power times 3 to the 9th power. Okay, what do I do with those indices? Of course, I add them, which gives me 3. The base remains the same. 3 to the 16th power. 9 and 7 gives me 16. All right, now let's look at 3 to the 6 divided by 3 squared. What am I going to do? If I look up here, when I divide, I subtract the indices. So 3 to the 6 divided by 3 squared is 3 to the 6 subtract 2, which gives me 3 to the 4th power. Very good. And moving on to the last one, for example 1, 10 to the 4th power raised to the power 3, or 10 to the 4th power cubed. Which rule is that one? That one is looking at rule number 3, or the one I have on the left there, where I multiply my indices. Now, how can I spot this one? It's one base and 2 exponents, a power to a power, or an index to an index, or an exponent to an exponent. We know that from video 7.1. So therefore, our answer for this one is going to be 4 times 3 is 12. Excellent. Pretty easily done. All right, let's move on to example 2. So example 2 is asking us to simplify the following expression so that it is in the form a to the n, where n is a number. Now, just to point out, the instructions are very important. We do have to read that because it's asking us to simplify. We're not trying to work anything out because we don't know what a is. So the operative word here is to simplify. Very good. So moving on to doing those questions. A to the 6th power times a to the 7th power. When I multiply, I know that I have to add my indices, which gives me a to the 13th power. Very good. Now, B. B is looking a little bit tricky. They're asking us to do more than one steps to this working, but we could do it quite easily. Let's take it one step at a time. So let's do our numerator first. Let's focus on the numerator of that fraction. A to the 4th power times a to the 2nd power, and when we multiply, we add our indices, which gives me a to the 6th power, and I'm just going to keep my a to the 3rd right there. Now, when I divide, please be very careful here. When I divide, remember, I'm not dividing the indices. The rule clearly states, and the proof clearly shows, I subtract. So therefore, this is going to be a to the 6 minus 3 is 3. Very good. I hope everyone understands that. And part C, pretty easy. A to the 4th power cubed. And what does that give us? Let's just keep our equal signs there. That gives us a to the 4 times 3 is 12. Now, that was pretty intense. 3 rules for us to look at, but hopefully we can get this done and move on to the exercise without any problems.